The instruction of this problem is solving, meaning we have to get all the angles for x in here going from 0 to 2 pi. In order to do that, step 1, we have to make sure we only have one trig function type. Right now, we currently have two trig function types, right? We have a cosine here, and we also have a sine here. They are two different trig function types. So we have two options. We can turn cosine into sine, that's option 1, and option 2, we can turn sine into cosine. Option 1 is easier. In order to turn cosine to sine, we do have a tool. We can use one of the Pythagorean identity that said sine squared plus cosine squared equals to 1, right? So the goal in here is that we have to manipulate around this equation, this Pythagorean identity, so that we can only isolate the cosine square on its own. So what we're going to do in here is that we're going to minus sine square from both sides. So let's minus sine square from both sides of the equation so that we only get cosine square on its own on the left hand side. So after that, we will get cosine square on the left hand side, and on the right hand side we would have 1 minus sine square. So this is the stretch work, right? This is like what we have to do before we get to the main problem. Now that we're ready, let's go ahead and plug this back into the original problem that we have in here. So we're going to do 2, and instead of writing cosine square, we're going to put it in red in here. We're going to do 1 minus sine square of the same angle, 3x, that we had from the original problem. And then we're going to copy and paste everything from the original problem down here. After this, we would use our arithmetic knowledge to do what we have to do to break out the parentheses. So for this step, I'm going to multiply the 2 on the inside. And I'm going to get 2 minus 2 sine squared 3x. And I'm just going to copy down whatever I haven't worked on with to here. And after that, I figure we have common terms. We have like terms. The 2 in here and the 3 and the negative 3 in here are like terms, right? So let's combine them. 2 minus 3, we're going to get a negative 1 in here. So let me just copy down the terms that we haven't used. So negative 2 sine squared 3x plus 3 sine 3x, and then minus 1, okay, equal to 0. You have two options. Matter of fact, you can just directly go into factoring right now if you want to, but to make it easier, to make it more simple, I highly recommend we changing all the sides in here. So we're going to flip the sides in here. Negative 2 sine squared, we're going to turn it positive. We're going to make it a positive term right here, right now, like this. And then 3 sine 3x, we're going to make it negative, right? We're switching the sign of all the terms that we have in here. And negative 1, we're going to make it a positive 1 in here and equal to 0. Okay? After that, we're going to try to use the greatest common factor if you have that option in your problem. And notice that we cannot do that right now because the 1, it doesn't have any sign of 3x to be factored out, right? So then this step in here, I'm going to do another color. Let's see, blue, right? So I'm thinking about the x method. And in order to perform the x method, first of all, I want you to multiply the a, c numbers together, meaning you're going to grab the first number, the front number, and the back number. You multiply them together. 2 times 1, you're going to get a positive 2 up here. The middle number in here is negative 3. I'm going to write it down here, and you're going to ask yourself, what are the two numbers multiplied to positive 2, and at the same time, they have to add up to a negative 3, right? Take 2 seconds to think about that. And I'm thinking negative 2 and negative 1, right? Because negative 2 times negative 1, you do have a positive 2. And negative 2 plus negative 1, you do have a negative 3, right? So the negative 2 and the negative 1 is the pair that we're looking for in this problem. So now you're going to go to the box. So first of all, let's draw a box. It has 4 spaces in here. It has 4 rooms in here, right? First thing first, I'm going to copy off the first term on the top left corner in here, 2 sine squared of 3x. And then last thing last, I'm going to copy off the +1 or just 1 on the bottom right corner down here. And now keep in mind that you just had the -2 and the -1 as the two new numbers to create, right? So I want you to put the -2 down here and the -1 up here, okay? Matter of fact, you can switch their spots. It doesn't matter where you put a -1 or a -2 at, as long as they are like across each other. They're taking the last two spaces on the box, then you're good to go, okay? And then make sure you put the attachment of sine 3x for the middle term next to the -2 and -1 in the box, like this, okay? So to finish up the box, what I need you to do in here is to find the greatest common factor. I need you to fulfill the outside of the box. So let me do it in purple. For the first row in here, what do we have in common? Well, I'm thinking of sine 3x. So let me just put sine 3x in here. For the second row, I'm going to ask myself the same thing, and I'm having a +1 because they don't have anything in common. Okay, so for the first column, I don't want you to factor it out anymore, right? I don't want to use the greatest common factor among the two boxes in the column in here. I want you to ask yourself, sine of 3x times what will get you 2 sine squared, okay? And I'm thinking 2 sine of 3x, right? So sine of 3x times 2 sine of 3x, I would get 2 sine squared on the inside of the box, okay? I'm going to do the same thing on the next column. I'm going to ask myself, sine of 3x times what gives me -1 sine 3x, right? And the answer in here would be -1, okay? Now let's double check if we have everything like correctly put down in the box, right? So 2 sine 3x times 1, I should have 2 sine 3x on the inside in here, but I don't. I have a -2 sine 3x in here. Uh-oh, there's something wrong, right? So you have two options. You can either make this negative or you can make this negative. Which one is easier? I'm thinking, well, let's try to make the +1 to be -1 in here, right? So then this box is checked. 2 sine 3x times -1, we do have a -2 sine 3x. And then how about this one? -1 times -1, we do have a +1. So we're good to go, right? And now I want you to use the outside layers to put everything together. So for the outside row, I have 2 sine 3x minus 1 as the first group. And for the column outside layer, I have sine 3x minus 1. Okay, and I have it equal to 0, like this. And now I want you to split each of the problem to be equal to 0, and we're gonna solve them separately from each other. Okay, so the first problem, I'm gonna do 2 sine 3x minus 1 equal to 0. And the second problem, to connect it, I'm gonna write the word or. The second problem would be sine of 3x minus 1 equal to 0. Okay, and after this, well, we're just going to use, again, our arithmetic knowledge to manipulate to get just the trig function isolated on its own. I'm going to go fast a little bit in here. I'm going to add 1 to both sides and at the same time divide everything by 2. So I will get sine of 3x equals a half. Okay. At the same time, for the other problem, if you want to, you can do them side by side, or you can choose to finish one problem first and then go to the other problem secondly. Okay. For this one in here, I would do sine of 3x equal to 1. Okay. Right. So now I need you to use your unit circle. I need you to look at the unit circle and ask yourself, sine of what angle the y value of what point equals to a half. Okay, so if you do the right thing, I'm pretty sure you will see sine of pi over 6 and sine of 5 pi over 6 would equal to a half. So we have two options, right? Let me use, I guess, pink in here, right? If you want to measure it down on the unit circle in here, Let me draw like a quick sketch of the unit circle. Sine equals to a half. I'm looking at this one. This angle and this angle in here, because the sine, they represented by the y value on a unit circle, right? So I would have 3x equals pi over 6. Don't forget the plus 2k pi. And then the other angle family, it would be 5 pi over 6 plus 2k pi. Okay? Let's finish one problem before we answer the next problem on the right side here. Okay? Let's just slide them up like this. Okay? So we only want the x. We don't want 3x. That's why we're going to divide everything, every single thing in here by 3. So I'm dividing this by 3. I would divide this by 3, this by 3, this also by 3, and this would also be divided by 3. Okay, so I would get x equals pi over 18, and you can definitely do this one in the calculator if you want to. The trick in here, the syntax in here, if you want to, you can do a 1 over 6 divided by 3. Okay, in a Casio, it will give you the answer as 1 over 18. And you just have to remember that the pi is always there. Okay, if you have a Texas, if you have a TI, there's a way to manipulate to go from decimal to fractions. Okay, and then the other ones, I'm just going to put 2k pi divided by 3. And fast forward, you can do this one in the calculator. 5 or 6 divided by 3, I'm having 5 pi over 18 divided by, well, 5 pi divided by 18. Okay, and this is 2k pi divided by 3. And let me move this one to the side. Well, actually, let me just erase it. How about that? Oh, convenient. There we go. And then now, let's get the other problem solved first. And we're going to talk about what does it mean to have an angle between 0 and 2 pi in a second. Okay? For our little second problem in here, right, you're going to ask yourself again, what angle in the unit circle in here gives us the y value, the psi value equals to 1, right? So let me draw a quick picture of the unit circle again. So this is our unit circle. And the y, it represents the psi value as always. So sine or y value equals to 1. I'm thinking about this angle up here, right? So that angle would be pi over 2. So this is pi over 2. 3x equals 90 degrees or pi over 2. Make sure you don't forget the plus 2k pi. Right, and now again, same thing. I want just the x by itself, so I'm gonna go ahead and divide everything by 3. Okay, and you can definitely use the calculator to get x on its own. This would be pi over 6, and this would be plus 2k pi over 3. Okay, and after this in here, keep in mind that the instruction of the problem, they want all the angles within the first cycle going from 0 to 2 pi. Okay, so our job in here is that we have to keep plugging the value for k until we get something that's not in the first cycle anymore, then we stop. Okay, so let me do it in this color. Okay, so first round, if k equal to 0, on the left hand side, I'm going to have x equal to pi over 18 and 5 pi over 18. On the right hand side in here, if k equal to 0, I would get x equal to just pi over 6. Let's do another round, right? Let's do another round k value. This time I'm gonna do what color? Red. If k equals to 1, let's see what I'm gonna get out of this, right? I'm gonna get pi over 18 plus 2 pi over 3. So you can do that in a calculator. If you plug it in, you would get, I would say this one is like 5 pi over 6. Actually, I can do it real quick in here. So 1 over 18, right, plus 2 over 3. This would be 6 times 2 is 13, actually, 13 pi over 18. And let me clean up this thing. And then if you do the same thing over here, right, if you plug in to this family in here, k equals to 1, then you're going to get 5 over 18 plus 2 over 3. So 12 plus 5, you're going to get 17 pi over 18. And then on the other side of the problem, if k equals to 1, x would be a 6 plus 2/3, right? So a 6 plus 2/3, you're going to get 4 plus 1, 5 pi over 6. And then let's do one more round because we're still within the first cycle, right? Everything is still under 2 pi. Nothing is out of control yet. Nothing is out of 2 pi yet. So let's do blue. K equals to 2. I guess is pink, not blue. So the x in here, it would equals what? I'm going to put it into the calculator. Okay, so give me 1 second. Let me clear this thing. So K, wait. K equals to 2. X would equal, so what we're going to do is that in a calculator, you would do 1 over 18 plus 4 over 3 this time, because K equals to 2, right? So it would be 4 over 3 for this guy in here, right? So we're going to do 1 over 18 plus 4 over 3 in a calculator. And that would be 6 times 4 is 24, 25 pi over 18, right? So let me clean this mess first. And I'm going to put 25 pi over 18 down here. And if we do the same thing for this guy, right, we're going to get 5 over 18 plus 4 over 3 this time, right? So it would be 29 over 18. 29 pi over 18 to be more precise. And for this guy in here, if k equals to 2, we're going to get x equal to 1 over 6 plus 4 over 3. That would be 9 pi over 6, which is 3 pi over 2. Okay. So let me get 3 pi over 2 in here.